So have you ever thought how messages are sent over the internet and hasn't get tampered? So the thing that is protecting the message from getting tampered is digital signature. So in this video we will understand how digital signature works and the scenario what would happen if there was no digital signature. So let's take an example of the normal case. So without digital signature, what would happen? A sender tries to send a message. Here I am taking an example of a university and that is trying to send a mark sheet. So here is the marks written and it would directly send over the network. And in the network, if there are any hackers, they would easily intercept this message and alter it, and receiver will receive the altered or manipulated message. Now receiver doesn't have any chance of identifying that this message is altered and he would think that the message is 100% genuine. So how to mitigate this case? So for this type of problem we use digital signatures. So digital signatures are nothing but a hashing algorithm is performed on the sender's message. So instead of sending the actual message in plain text, what sender does, he hashes the message using some standard hashing algorithms like SHA-256. And the fact about hash is that if there are any small changes in the plain text message, it will have drastic change in the hash. So after converting the message into the hash, what he does, he encrypts the message using his private key or the sender's private key. So where he gets this private key, he uses an algorithm such as RSA algorithm that gives him two things. One is the private key and second is the public key. The private key is meant to be kept with the sender and it's never to be made public, and the public key can be easily shared in the internet with the receiving side or to any other parties that would like to decrypt the messages. So now after creating the hash, the sender encrypts the hash using his own private key, and after that he gets encrypted hash. So now instead of just simply sending the plain text message, what he shares the message as well as the encrypted hash to the receiver side via the internet. Now after receiving both of these things, what receiver does is that receiver decrypts this hash using the public key of the sender, which the sender already have sent prior of sending this message. Now with this public key he can easily get the original hash, that is this one. And as the hashing algorithm is common, so the receiver can independently compute the hash of the received message as well. Now here is the interesting part. If there is any alteration in the message during the transmission, as I have already said, for any change in the message the hash will change. So when he is independently calculating this hash, if there is a change in the message, his independent hash will also get changed. But this cannot be changed because this is encrypted and then sent using the private key. So this can never be altered in the network. So after getting both of these hashes, the receiver can do what? He can easily compare both of these hashes, and if there is a significant or if there is a slight difference also in the hash, that means the message has been altered during transmission. And if both of these hashes are same, then the signature is verified. That means the message has received without any alteration. And this is how digital signature basically works. So now this is the theoretical part. Now we will see the code implementation, how this actually works. Now let's start with the coding part. So I am here on my online JavaScript compiler. So first we need to import the crypto library. Now we have to make the public key and the private key. Here I am specifying that we'll be using RSA algorithm. Now I am declaring the message. Const message equals to, let's say, maths, and they have got 90 marks. Now we will sign this message or hash. So this is the syntax of hashing the message. We are giving the message over here, and this will form the hash of the message. Now what I have done, I have used my private key in the sender side and created the signature, which I will share with the message. Let's console log it and see what is in there. Let's run the code. There is an error. Okay, here you can see this is a signature, and that has been made by my own private key. So no one could have made this. So after that, let's now send this message to the receiver side. Now what I am doing in the receiver side, the receiver is independently calculating again the hash using the 256 SH256 algorithm and of the same message that has been sent. Now in this step, what I have done, I have used the public key, which I can easily get of the sender, as it's public, he will definitely share it, and I have the signature that he has sent me. So with both these things, I can validate that the message is valid or not. And I have this verify is coming from here. So here the message is already given. So what this verify has, it has the hash of the message which I have given here. So what are the three things I am having here? I have my hash that is coming from this verify, and that verify is a method, and after that I am having my the sender's public key and the signature. So with the public key and the signature, I will, in this step, I am decrypting the hash or the signature. Here I am decrypting the sender's signature or the encrypted hash that he has sent me. So I have the hash that is in the encrypted form, which will never get tampered, and I have individually calculated the hash of the message. So what this verify method does, it basically just compares both the hashes that they are same or not, and if they are same, it just returns true in the valid, or if they are false, it will return a false if they are not similar. So let's run the code and see. So yes, here you can see verified true because the message was not altered. Now think of an example. Let's say const message 2 equals to maths, and I have altered the marks with 60. Now here, instead of giving message, I am giving message 2, and I am acting as a hacker in between, and I have changed the message during transmission. Now this code can easily identify that something has been changed. You can see here verified false. That means the receiver is being able to understand the authenticity of the message he is receiving. So this is all about the video. Thanks for watching. See you in my next video with some new topics. Bye.